Hi, and welcome to my channel Catch the Crooks. Today, we'll be reviewing the first paper on the series of fraud analytics review papers. And today's paper is a comprehensive survey of data mining based fraud detection research by Clifton Fua. This encapsulates 10 years worth of research done in the field of fraud analytics, and there are two main objectives in this paper. The first is to find or assimilate all the data analysis done in fraud analytics, and second is to identify methods that were used and to experiment these methods in different fields, such as whether methods can be used for uh, fighting money laundering or terrorism financing or spam detection for that method for that matter. So let's get into it and let's review this paper and see what the author is talking about. So I selected this paper because this paper is a summary paper, which means it summarizes a lot of research in this field, and it would give us a broad high-level view of what's happening in the space. This paper encapsulates all the research done till 2004. So it's a bit outdated, but it's still one of the best papers I could find. And Clifton was kind enough to grant me the permission so that I can review this paper on this channel. So let's get into it. So in this paper, the author talks about what are white collar criminals and how do we apply data mining for fraud analytics, and how do we measure if our analysis is correct. And we will also talk about popular fraud detection techniques which are used in different industries. Uh, Broadly speaking, how do we classify fraud? As you say, as you can see here, the fraudsters can be classified in managerial, external, or employee. So managerial and employee can be classified into a bucket called internal fraud, and everything outside of that, which is a criminal or average person trying to dupe a company or an organized syndicate, would fall under the external fraud bucket. So I have made high-level notes and highlighted the points which I feel would be most relevant to this paper. So the main purpose of the fraud detection is to identify general trends and of suspicious or fraudulent applications and transactions. In the case of application fraud, the first applies for insurance entitlements using falsified information, and apply for credit and telecom product and services using non-existent identity information on someone else's identity information. So, and in case of transaction fraud, the fraudster takes over or add to usage of an existing legitimate credit or telecom account. So, yes, broadly, I have seen in my day-to-day work experience that there are first-party fraud where a known customer um, credit card is compromised and their account is being used, or they try to take someone else's credit card and put in their account to launch a fraudulent claim. Or there could be third party fraud where there is identity takeover and someone's um, identity is compromised and the fraudster uses this identity to create an account and take out a plan. Um, and there is another case of account takeover, whereas existing customer's account has been hacked by cyber criminals, and these accounts are being misused by the fraudsters for their own benefits. So let's talk about the data structure. Ideally, in the world, there is not a lot of structured data available. This author was able to find different data sets, telecom, credit card, insurance, and internal fraud domains, and tried to with different examples of the fraud. So as you can see, the internal fraud, there are limited examples, but in telecommunication, because you have a lot of data, you can get a lot of examples of fraud. So this is just a high view of the data set. And this out here the author summarizes how much fraud was present in as compared to total data available. Um, so one of the drawbacks initially was we had limited data access to fraud because it's all sensitive, or in most cases PII data, which means a personal identifiable information. So the companies would not be willing to share this data with anyone. In contrast to the structured data collection for fraud detection, unstructured email data will require effective feature selection or text mining operations. So we can get a lot of information from unstructured data as well. So in the case of Enron scam, you would know that there is a huge email data set available, publicly available nowadays for analysis, and that data set was used to identify who were the main culprits in the scandal. Then we come to how do we assess the performance. Most fraud department place monetary value on prediction to maximize cost savings or profit according to their policies. So the biggest contributor or the biggest way we can say that the we are doing well in catching fraud is by looking at how much savings have been generated or how much loss has been prevented. That all goes into the profit of the company. Well, suppose a company is selling something or providing a service, there's a huge margin cut based on all the if you remove all the costs, and this is a major portion of the cost, which takes away from the company's bottom line. In fraud, it's more useful to reduce false negatives as compared to false positives, because if you're stopping a good customer, you might not be losing as much as you might lose when a fraudster, which usually, who, like in my experience, I've seen they usually go for a higher plan or they go for a higher highly valued goods so that they can get maximum out of their uh, transactions. But so they usually their transactions amount are way higher than a average person's daily purchase. So there's a high cost associated to all of that. Now, the author talks about various methods, and the first method proposed for anomaly detection is a semi-supervised method, in which was done by Lee and Jian in 2001. They propose entropy, conditional entropy, relative conditional entropy, information gaze, and information cost. These are the measures they use to identify how good they are performing. Other important considerations include how fast the fraud can be detected, what are the types of fraud that were detected, whether the decision was made online in real time or was it done on a batch mode. These are the main parameters you look for when you're doing cost or fraud detection, and how comparing between solutions, how accurate they are or how profitable they are. Now we come to the methodologies and techniques which are used for fraud detection. So one of the primary methods used is using a blacklist. So once a fraudster has been identified, their information is put into a system, and any further transactions or checks or accounts are blocked. But usually fraudsters are smart and they keep on changing the modus operandi, so we have to keep on updating the blacklist. Second method, what we can adopt is using a supervised uh, approach, in which we use all the previously labeled transactions and try to assign a risk score to any new transaction we see in the system. But for this, we do need to label, or we need to have a lot of label data. The techniques used in supervised detection is neural networks or support vector machines. And this was one of the first papers was by Bosch and Riley in 1994. And later on, there was further work done by um, Barley Bars in 2003, where he proposed a multi-layered neural network with exponential trace memory to handle temporal dependencies in synthetic video-on-demand log data. So using videos, they could use the temporal features of the video and see if fraudsters can be identified. In 2002, a fuzzy neural network with parallel machines to speed up code production was proposed for customer-specific credit card fraud detection. So there are a lot many techniques using support vector machines, neural network, and Bayesian networks, and there are nearest neighbors and a lot more decision trees methods. So I won't go on into all the techniques which are mentioned in this paper, but it does cover variety concepts which are used to identify and detect fraud. Now, one of the examples here, the decision tree, rule indicator, and case-based reasoning have also been used. Introduce systematic data selection to mine concept drift and possibly insufficient and data streams. So, as you can see, there are a lot of examples of various methods and techniques used in supervised machine learning approach. Now let's look at the other approach for detecting fraud. The second approach is hybrid approach with label data. So if you combine multiple supervised learning algorithms such as neural network, Bayesian networks, and decision trees, and try to improve the results, then you would come up with a hybrid, or we also call it ensemble method of detecting fraud. So this does result in high cost saving and a better efficiency in credit card detection. Um, and this is a popular technique because it minimizes the bias of our predictions. The next one is a hybrid between supervised and unsupervised. So many a times we don't have label data, but we can use unsupervised to see if any sort of transaction, especially in the telecommunication domain, falls above or are clearly distinct to the usual customer behavior, and then use those transactions and classify them as fraudulent, and then you can use a supervised classifier on top of that to identify the patterns of those separate identified clusters, and then stop those kind of transactions going forward. So that's another novel approach, and that's mostly used in telecom industry. Then we go to semi-supervised approach with only legal or non-fraud data. So in this case, you come up with some rules or association rules using a priority algorithm and or increase diversity by calendar schema. So you apply a set of rules and then you use those rules in a legitimate transaction database and discard any rules that matches that data. So if the rules you come up with exactly matches with any legitimate transactions, you remove all of them, and then you monitor the remaining rules, and then you try to put them on anomalies or fraudulent data, and then you also keep on modifying this rule and some kind of genetical modification or just slight tweaking on the threshold values to see if they are effective, and then keep the ones which are performing well and remove the ones which are not performing well. So that's another semi supervised approach for um, identifying and updating your rule schema. Finally, we come to the unsupervised approach where you can use link analysis or graph mining, which is again a hot research topic in anti-terrorism law and law enforcement and many security agencies, where you can basically find relationships within different groups, and then you try to block them. So it is also used in telecommunication fraud detection, and you use flexible encoding data using different colors, position, size, and various visual characteristics with different views and levels. Um, and what we have found is fraudsters are usually connected to each other. Sometimes it's the same fraudster committing multiple frauds, or be a group of syndicate which are working together to create fraud. And with them, we do find similarities between their modus operandi and are able to distinguish what are legitimate transactions and what are fraudulent transactions. Now there are critiques on uh, with all these methods. Um, a lot of academic research methods do not apply in real world data. So we have to be cognizant of that fact, and then you have to keep playing with it, understand what the patterns are, and adopt to those real world patterns. If you might have unskewed balances, skewed classes, or there might be too complex neural network which would not work in real data, or they might be slow in predicting, which might not be as useful. Um, so we see there is a combination of rule-based and machine learning, which works pretty well in fraud detection domain. Now, there are other domains which are very similar to fraud detection, which is terrorism detection or anti-money laundering, which is financial crime. and we can also use it for the spam detection. So I hope you like this video and you got a quick overview of the fraud analytics domain. I will keep coming up with more interesting research in this space, and hope to see you on this channel. So if you like this video, please click like and subscribe to my channel, and I'll be bringing in more interesting content for you all. Thanks.